This is a huge discovery, and we think that it's a huge discovery.
When scientists find a new exoplanet, they get excited because it could mean that there is life there. For hundreds of years, people have been interested in the idea of finding life beyond Earth. That dream could soon come true with the help of the James Webb Space Telescope. Proxima Centauri is the nearest star system to us, and the telescope has found an interesting fact about it. Scientists are confused and interested by Proxima B's strange artificial lights that make it stand out from the other planets in the system. Could this be the long-awaited proof that there is intelligent life outside of our solar system? How do scientists know if these lights point to the possibility of intelligent life on Proxima b? Come with us as we talk about how the James Webb Telescope found city lights 4.25 light-years from Earth. People have always been very interested in the mysteries of the world. Our natural desire to explore the Earth and sky keeps pushing us with the help of new technologies. Even after thousands of years of civilization, Earth is still the only world we know of that has life on it. So the age-old question still stands. Are we the only ones living in the world, or are there other civilizations out there waiting for us to find them? There is a hard question that needs to be answered. In 1984, two American scientists, Jill Tarter and Thomas Pearson, started a project called SETI to do just that. The goal of this non-profit project is to look through space for radio waves that come from space. These radio waves can move very far and are thought to be the main way that aliens might be able to talk to us. In order to do this, 42 radio telescopes in the Cascade Mountains in California were carefully set to listen to the bands of space. These radio devices, which were made to pick up any signal from space aliens, were called the Allen Telescope Array. Over many years, scientists have looked up into the sky for reliable signals. However, there is still no solid proof that these signals come from an alien society. But new information from NASA suggests that the James Webb Space Telescope, JWST, may have seen fake city lights from a planet close by. Is there any truth to this? Let us find out. The launch of the James Webb Space Telescope went very well and is a huge step toward understanding the world better. This huge telescope, which is about 1 million miles from Earth, lets us see into the very beginning of the world. It makes it easier to see things that were hard to see before, which helps us understand how galaxies, stars, and planets form. Astronomers use the JWST's state-of-the-art cameras and filters to record and study the complex colors around stellar objects. Scientists can use JWST to find and learn useful things about the chemical makeup and physical features of very far-away celestial bodies. They are able to do this by focusing on certain types of light waves. JWST does more than just look at other planets. It also searches the atmospheres of those worlds for signs of life. It has made some of the most amazing discoveries because it can see beyond the limits of time and space. For instance, astronomers have found more mass in the universe than was thought before. It was hidden in a few very large galaxies. This discovery has made people question what they thought they knew about the universe's shape and size. As people start to explore the farthest parts of the universe, the JWST will be a key tool in figuring out the mysteries of faraway worlds and adding to what we know about the universe. 20 years ago, the space beyond our solar system was mostly unexplored and didn't have any known worlds. But since then, scientists have found more than 4,000 exoplanets orbiting faraway stars. This is a truly amazing example of how far people have come in their creativity and technology. NASA says that this list of exoplanets may only be the tip of the iceberg when it comes to the number of them in the universe. They think that there are trillions more out there. Scientists are still looking for alien homes beyond where we have been before as they continue their never-ending search for life beyond Earth. As luck would have it, while the Galileo spacecraft was traveling to Jupiter, its spectroscopic device showed an unusually clear pattern of light that pointed to vegetation on Earth. The vegetation red edge is a unique find that is the first time scientists have found a biosignature. The red edge has a different view of alien life because it focuses on how it reflects light. It is hoped that the JWST will help solve the mysteries of life on other planets. It will do this by carefully mapping the orbital parameters of possibly habitable planets far from their suns that are in the habitable zones of their alien parents. If these signs are picked up, they could be very important in the search for intelligent life beyond Earth. It will be the start of a new journey for us as we try to figure out how the world works. As sunshine moves through the layers of the atmosphere, the atoms and molecules in these layers take in the broken-up light, which has different wavelengths. Because of this absorption, a typical spectral pattern appears, which is like a unique fingerprint that can be read using spectroscopic analysis. Researchers think that the JWST will be able to pick up light from a star as it hits the atmosphere of a planet. So, the JWST could be the key to finding out what kinds of things are in the atmospheres of exoplanets, which is a key sign of whether or not they could support life on Earth. Planets about the size of Earth that have atmospheres full of oxygen, nitrogen, and carbon dioxide, like Earth, might have conditions that are good for life as we know it. But the lack of expected elements or the presence of strange compounds could point to other types of life or even advanced technology societies. Researchers have found that chlorofluorocarbons, CFCs, which are man-made chemicals mostly used for cooling and industrial reasons, might help them prove that there is a civilization on other planets. If the JWST finds some of these man-made chemicals in the atmospheres of exoplanets, it will be strong evidence that there is life beyond our solar system. This is a very interesting project for scientists who study the universe because it opens up new ways to learn about the atmospheres of other planets and the chance of strange civilizations living beyond the Milky Way. Undoubtedly, the disclosure regarding extraterrestrial life is marked by several potentialities that transcend the constraints of terrestrial biology. Although we typically imagine life flourishing in moderate climates similar to our own, the actuality can be much more diverse and harsh. Extremophiles, primarily consisting of bacteria, are a captivating collection of organisms that defy our understanding of what constitutes a good home. These resilient organisms can easily endure and thrive in environments that are commonly characterized as quite harsh. Extremophiles have remarkable resilience in the face of harsh conditions, enduring temperatures as high as 250 degree F and pH levels below 3. These are remarkable instances of the resilience of living organisms in challenging environments. Hence, the boundless expanses of the universe and the myriad habitats it encompasses indicate that our quest for alien life should be comprehensive. While the planets described bear similarities to Earth and orbit stable stars similar to the Sun, it is important to consider alternative possibilities as well. Promising targets for investigation could encompass exoplanets circling red dwarf stars, M-stars, which are more prevalent in the cosmos. Nevertheless, despite their diminished luminosity and lower temperatures in comparison to our Sun, these stars present distinct possibilities for exploring the potential for life in various habitats. The extended duration of red dwarf stars' existence offers ample opportunities for the gradual and intricate processes of the origin and development of life to occur. The TRAPPIST-1 planetary system, situated at a distance of about 40 light-years from Earth, is highly alluring as a primary objective for the James Webb Space Telescope, JWST, project. This remarkable system comprises a faint red dwarf star and 7 terrestrial planets of similar size, which orbit the tranquil red dwarf star. 3 of these identified planets are classified as habitable and are very probable to possess water on their surfaces. Despite being smaller and cooler than our Sun, the TRAPPIST-1 star generates a gentle and terrestrial-like illumination that appears conducive to sustaining life on its orbiting planets. Proxima Centauri stands out as a promising star among the many celestial bodies in the cosmic region. Proxima Centauri, located a mere 4.25 light-years away from the Sun, holds the distinction of being the nearest star to our own. Despite its dim luminosity, this star is observable. Nevertheless, the limited brightness of the star necessitates that any potentially inhabitable planets in its orbit must remain in close proximity. The proximity of any habitable planet to Proxima Centauri must be around 20 times closer than Earth is to the Sun. Unless this requirement is met, none of its planets can maintain life in the same way as our world. Astronomers made a fascinating discovery on August 24, 2016. They found a planet that is 1.3 times the mass of Earth and is situated in the habitable zone of Centauri. This zone, reminiscent of Goldilocks, provides an optimal equilibrium of light intensity that is precisely calibrated to thaw ice for water and perhaps support the growth of life's building blocks. Proxima is an astronomical anomaly that revolves around Proxima Centauri, its parent star. Located a mere 4.6 million miles from its little red star, this planet faces numerous circumstances that jeopardize its capacity to support life. Proxima b is in close proximity to its host star, Proxima Centauri, resulting in its exposure to intense solar winds that have the potential to deplete its atmosphere and render it devoid of life. However, despite the challenging conditions, Proxima b is able to benefit from the illumination of its little star, receiving an adequate amount of sunlight to sustain temperatures similar to those found on Earth, allowing water to exist in its liquid state. Nevertheless, due to the planet's proximity to its star, it is highly probable that tidal locking occurs, resulting in one hemisphere being constantly exposed to bright sunlight, while the other remains in complete darkness. The arrangement has a resemblance to the dynamic between the Moon and Earth within our solar system. Proxima Centauri, although having only 18% of the mass of the Sun, emits a feeble luminosity that is far lower than anticipated. Proxima Centauri, located very close to Proxima b, at a distance of only 5% of the distance between Earth and the Sun, defies traditional predictions. It suggests that Proxima b may not have the intense heat that one would anticipate for a planet located in such close proximity to its star. Although Proxima b faces difficulties because to its proximity to its star and the risk of losing its atmosphere to solar winds, it presents intriguing opportunities. If the planet maintains a protective atmosphere that can effectively hold heat, it is possible for liquid water to exist on its surface. This would potentially allow for the exciting possibility of habitability outside of Earth. Due to Proxima b absorbing only 65% of Earth's total solar energy, the likelihood of it supporting life is significantly diminished. The planet's potential state of tidal locking results in significant temperature variations between its extremely hot day and freezing night. Proxima b is exposed to severe environmental circumstances due to its close proximity to Proxima Centauri. These conditions include high levels of radiation, such as X-rays and ultraviolet light, which render the planet unsuitable for supporting life as we understand it. In addition, Proxima b is subjected to intense bombardment of high-energy particles during star flare-ups. If a planet does not possess a protective magnetic field, similar to that of Earth, these bombardments have the potential to remove its atmosphere, thus eliminating the essential circumstances required for life to flourish. According to realistic modeling, it is suggested that planets like Proxima b, which are tidally locked, may undergo a rapid collapse of their atmosphere due to the freezing of volatile gases on the side of the planet that is always in darkness. Proxima b does not have means to replace its atmosphere like Earth does through volcanic activity. The enigma surrounding Proxima extends beyond its surface characteristics to its capacity for hosting sophisticated civilizations. Currently, our understanding of Proxima b's volcanic activity and the intensity of its magnetic field is limited. Nevertheless, the alluring prospect of an atmosphere gives rise to conjecture over the planet's capacity to support life. If an atmosphere is present on Proxima b, it would imply the presence of seas and increase the possibility of life. The search for evidence of extraterrestrial civilizations on Proxima b has become more intense, motivated by the idea that these aliens may have developed clever strategies to overcome the planet's hostile environment. An innovative proposal suggests the installation of expansive solar panels on the daylight side of Proxima b. These panels would utilize the star's radiation to provide illumination and warmth to the continuously dark and freezing night side. This undertaking has the potential to convert the desolate terrain into inhabitable areas capable of sustaining life. Astronomers are currently engaged in a competitive pursuit to ascertain whether Proxima b transits across the line of sight between Earth and its star, following its recent discovery. These motions would enable scientists to quantify the dimensions and weight of the planet. Afterwards, they will compute its density, verifying its rocky composition and providing insights into the components that make up its rocks. Moreover, the starlight that traverses through the atmosphere of Proxima b during its travels offers valuable insights into the makeup of its atmosphere and its potential for supporting life. Notwithstanding the difficulties, the investigation into the enigma of Proxima b continues to be a top concern. This urge is fueled by the insatiable human desire for knowledge and the potential existence of extraterrestrial life outside our solar system. Another aspect to take into account is the tumultuous nature of Proxima Centauri, which has the ability to produce significant flares. This enhances the intricacy of exploring the livable nature of Proxima b. Astronomer David Kipping from Columbia University characterizes the star as tricky, emphasizing the difficulty presented by its fluctuating heating patterns. Unlike most rocky planets, Proxima does not absorb sunlight and emit infrared radiation. The infrared signature of the object is distinct from that of its host star, Proxima Centauri, providing a rare chance for observation. The James Webb Space Telescope, JWST, is capable of detecting infrared wavelengths, making it a valuable tool. The distinctive infrared heat signature of Proxima will enable us to uncover the concealed mysteries of its atmosphere. The advanced infrared imaging capabilities of the JWST are fully equipped to uncover the enigma of Proxima b's atmospheric constituents and provide unparalleled understanding of its potential habitability. Furthermore, the JWST's ability to detect infrared radiation allows for the investigation of Proxima b's nocturnal hemisphere. Although it is difficult to detect weak artificial light in the midst of cosmic blackness, the superior technology of the JWST allows it to perceive even the most subtle traces of light. The James Webb Space Telescope will have the capability to confirm the existence of city lights on the nocturnal side of Proxima. The telescope is capable of detecting artificial illumination, even if it is as dim as the lights we now use at night. However, it can only detect this illumination if it falls within a frequency band that is 1,000 times narrower than the band of starlight. The environment of Proxima b offers a distinctive link between its surface characteristics and interactions with the star, which is fascinating. If several solar panels are installed on the planet's illuminated side, they will capture and utilize the radiant energy emitted by the star. Simultaneously, its spectral edge effectively reflects incoming light rays. During Proxima b's orbital journey around its host star, both its day and night sides go through similar cycles marked by moderate daytime temperatures and chilly evening temperatures. Nevertheless, the extent of temperature variations depends on the composition of the globe. Without an atmosphere, Proxima b would see a significant contrast between its day and night sides. In the absence of atmospheric gases and oceans, the day side would emit heat in a manner similar to a black body, while the night side. The side abruptly descends into a frigid abyss. Astronomers can obtain vital information on the composition of Proxima's atmosphere by analyzing the extent of temperature fluctuations. The JWST will utilize its exceptional infrared imaging capabilities to analyze the planet's thermal emission, yielding crucial information regarding its atmospheric features. Notably, the JWST's orbit around Earth is synchronized with Proxima's orbital period, allowing for comprehensive views of both its daytime and nighttime hemispheres within a span of 11.2 Earth days. Once it is confirmed that Proxima has an atmosphere, the subsequent course of action would involve scrutinizing its atmospheric chemistry to determine its potential for supporting life. Gases like as oxygen, water vapor, and even methane, if found, serve as reliable markers of livable circumstances and the potential existence of life. Nonetheless, the research necessitates the careful and thorough capture and examination of light rays that interact with or traverse through Proxima's atmosphere, which is intrinsically a difficult task. While the James Webb Space Telescope offers extensive possibilities for studying planetary atmospheres, its primary goal is distinct. The telescope is specifically designed to analyze the fluctuations in methane, carbon dioxide, and water vapor levels. While the JWST may have limitations in detecting bonded oxygen, which is a strong sign of life, it still has motivations to explore other molecules. This include ozone, which can potentially offer insights into the current state of vitality in the Earth's atmosphere. Furthermore, the JWST has absolute capability and is restricted to observing only a select handful of the nearby, potentially habitable planets. Astronomers are utilizing ground-based observatories, such as the Extremely Large Telescope, EELT, to carry out a more thorough research of the atmosphere. The ELT, scheduled to commence operations in 2028, possesses a distinct advantage in its ability to explore the atmospheric composition of remote exoplanets at greater depths. The data will offer detailed and clear understanding of their potential to support life. The James Webb Space Telescope, JWST, is an essential instrument in our pursuit to comprehend far-off exoplanets, as we anticipate the launch of upcoming space observatories. Although the JWST currently has several limitations, it has the potential to offer essential insights that will significantly influence our strategy to exploring exoplanets in the future. Upcoming space telescopes are designed to decrease the luminosity of a star that a planet orbits, enabling astronomers to concentrate on the light that is reflected by the planet. This can be accomplished by employing internal masks or utilizing huge external umbrella-shaped satellites, similar to obstructing light with your hand to enhance visibility of distant objects. Telescopes can enhance the examination of the planet's feeble reflected light and conduct a thorough analysis of its atmosphere and possible habitability by reducing the brightness of the host star. Nevertheless, there are difficulties in differentiating between gases emitted by living organisms and those resulting from geological phenomena such as volcanic eruptions. Astronomers endeavor to gain a comprehensive understanding of the features of exoplanets in order to discern potential indicators of life and distinguish them from misleading results. The James Webb Space Telescope, JWST, provides a glimpse into the progress made in studying exoplanets, suggesting the thrilling findings that lie ahead as we continue to explore the cosmos through our curiosity and technological developments. We are entering a new phase of comprehending the universe and our position in it. Regardless of the existence of extraterrestrial life, the consequences of our explorations are significant and will influence our understanding of existence. Thank you for viewing. Before you leave, be sure to click on the video displayed on your screen to access further awe-inspiring videos similar to this one.